Welcome back, learners, to another deep dive.
Yeah, welcome back.
You're here because you wanna really get a handle on things pretty quickly, thoroughly, but without cutting corners.
Yeah,
And that's what we do here. So we're glad to have you back.
that's right.
So today we're tackling something that might seem pretty basic,
Mm-hmm.
um, but I think it's worth spending some time with.
Absolutely.
It's expressing one using unit fractions, and then kind of the other side of that same coin is the relationship between fractions and division.
Right.
Um, so our sources for today are excerpts from u8l69.pdf.
Yep.
So these are basically a bunch of lessons and exercises and examples.
Yeah, great examples.
And our goal today is really just to make sure that you see exactly how these unit fractions build to a whole, and also how fractions are really just another way of talking about dividing things up.
Yeah, exactly. We're going to see how those are two sides of the same coin.
Okay, so let's jump in with expressing one using unit fractions.
Mhm.
And this might sound a little technical, but it's really just talking about the simplest pieces of any fraction.
Yeah.
So our source starts out with a rectangle
Okay.
that's been cut into 3 equal pieces.
Mm-hmm.
And it says each one of those pieces is 1/3
Right.
of the whole thing.
Yeah.
And so if you put all 3 of those thirds back together, what do you get?
You get the whole rectangle back.
Yeah, you get one whole rectangle.
Yeah, it's just like if you were to break something apart,
Yeah.
you can always put it back together as long as you have all the pieces.
Right, and it's really just about understanding, like, what are those individual pieces? What are those building blocks
Right.
that make up the whole?
Yeah.
And so they give some more examples.
Okay.
So a rectangle divided into 4 equal parts.
Mm-hmm.
Each part is 1/4.
Mm-hmm.
And when you have all 4 of them, you have 4/4,
Which is one.
which is one whole.
Yep.
Then they have a circle that's sliced into 6 equal pieces. Each is 1/6. And together, those 6 pieces make 6/6, or one whole circle.
Right.
And then another rectangle, this one showing 8 equal sections. So 8/8 represents the whole.
Makes sense.
And so one thing to point out here is that the bottom number, the denominator, is always telling you how many equal parts the whole has been broken into.
Right.
And when the top number, the numerator, matches it,
Mm-hmm.
then you've got the entire thing. You got the whole thing.
Yep.
So far, so good, I think.
Yeah, pretty straightforward.
Okay, so now our source throws in a little bit of a prediction.
Okay.
It says, how many fifths do you think it would take to make one whole? So just think about that for a second. How many fifths to make one whole?
I'm going to say 5.
Yeah, it is 5.
Okay.
So you've got 5 equal parts, each one being 1/5, come together to form the whole.
Yeah.
Pretty easy to see when you kind of visualize it that way.
Yeah, it makes sense.
Okay, so then we get to the check section. And this is where they really hammer home this idea. With, they have a circle divided into halves,
Mm-hmm.
a square into fourths, and a hexagon into 6.
Okay.
And the exercise asks us to label each of those unit fractions.
Right.
So for the circle, each piece would be labeled 1/2.
Uh-huh.
And then it asks how many of these pieces make one whole.
Right.
So for the circle, it's 2/2. For the square, it's 4/4.
Mm-hmm.
And for the hexagon, it's 6/6.
Makes sense.
So again, it's really just about seeing those
Yeah.
individual pieces coming together
Yeah.
to make up the whole.
Yeah, it's really that simple.
Okay, so then we get to exercise 10.
Okay.
And this one really drills down on the concept using different shapes.
Mm-hmm.
So it asks, how many halves make one whole rectangle?
2. Yeah, exactly.
How many thirds make one whole circle?
3.
3. How many fourths make one whole triangle?
4.
4, and it goes through, 8, 6, 12, even 20ths.
Oh, wow.
Using all these different shapes, pentagons, octagons. And the idea is just that you're seeing it applied across all these different visuals
Mm-hmm.
to really kind of solidify that core idea in your mind.
Right.
So no matter what the shape is, if it's divided up into
Equal parts.
equal parts,
Yeah.
and you have all those parts, then you have the whole.
Well, then you have one whole. Yeah.
Okay.
Makes sense.
Okay, so then we move on to exercise 2.
Okay.
And this one is interesting because it kind of flips the question on its head a little bit.
Oh, okay.
So instead of asking you how many unit fractions make 1,
Mm-hmm.
it gives you the 1 and asks you to fill in the missing numerator.
Okay.
So for example, it says 1 equals blank over 3.
Oh, okay. So we have to fill in that top number.
Yeah, exactly.
Gotcha.
And so the light bulb should go on there.
Yeah.
And you can say, oh, well, the top number has to be the same as the bottom number to equal one whole.
Yeah, because if it's divided into 3 parts,
Yeah,
then we need all 3 parts
exactly.
to have the whole.
Yep. And they do this for 7, 9, 13, 10, 20, 25,
Okay.
even 36. So they really give you a lot of practice with that.
Yeah, so that you really get that relationship.
Yeah, it's a good way to check if you're really understanding it.
Makes sense.
Okay, so then exercise 3 builds on that.
Mm-hmm.
Um, it gives you some statements
Okay.
and asks you to say if they're true or false.
Oh, okay, like a little quiz.
Yeah, exactly.
Gotcha.
So, for example, it says 1 equals 7/8.
Okay, well, we know that's false.
Yeah, that's false.
Because it's one little piece away from
Exactly, from being the whole.
Yeah, and so it's just, again, reinforcing that idea
Mm-hmm.
that the top number and the bottom number have to be the same
Yep,
for it to equal 1.
makes sense.
Then they have another one that says the number of sevenths that make one whole equals 7.
Okay, that one's true.
That one's true, yeah.
Okay,
And they have similar ones for fourths and halves and things like that.
gotcha.
So it's really just making you think about that relationship. Mm-hmm.
And if you understand it,
Yeah.
you'll be able to answer those pretty easily.
Yeah.
Okay, so then for those of us who are more visual learners,
Yeah.
exercise 4 is really helpful
Okay.
because it shows you fractions like 5/5, 8/8, 6/6, 4/4,
Mm-hmm.
and it asks you to match them up with pictures of shapes that have been divided accordingly.
Gotcha.
And all the parts are shaded in.
So we can see it visually.
Yeah, you see it visually. So you see like a circle cut into 5 pieces
Mm-hmm.
with all 5 colored in
Mm-hmm.
for 5/5, and then a rectangle with all 8 sections shaded for 8/8, so on.
So it's really just showing us what we've been talking about.
Yeah, it's just like that direct visual confirmation
Makes sense.
of everything we've been talking about.
Yeah.
Okay, so then the last little piece in this section on expressing one using unit fractions is a challenge.
Okay, I love a challenge.
Yeah, me too. So this one shows a picture of a football team, and it says that each player represents a unit fraction of the whole team.
Gotcha.
And so the question is, how many players make up the whole team? So just think about that for a second.
Okay, so if each player is like a piece of the pie, so to speak,
Yeah,
then the number of players would have to be whatever that denominator is.
that's right.
Right, because if we're thinking of the whole team as one whole unit,
Yeah.
then each player is a fraction of that.
Yeah, and so the number of players is both the denominator and the numerator in this case.
Right, because we're talking about the whole team.
Exactly.
Okay, cool.
So it's a fun little way to kind of solidify that concept.
Yeah, I like that.
Okay, so we've got a good grasp, I think, on how these unit fractions come together to make a whole.
Mm-hmm.
Let's switch gears a little bit and talk about the relationship between fractions and division.
Okay, yeah, this is where it gets really interesting.
This is where it gets really interesting, and you start to see how these two seemingly separate ideas are actually totally connected.
Oh.
So the source starts out with a really relatable example. It says, imagine there's a swimming tournament
Okay.
with 12 students, and 1/3 of them are girls.
Mm-hmm.
How do we figure out how many girls there are?
Okay.
So first, we can imagine those 12 students as individual counters,
Mm-hmm.
like little, chips or something.
Okay.
And then the next step is to divide those counters into 3 equal groups.
Okay, like, because we're talking about thirds.
Exactly.
Makes sense.
And then to figure out how many girls there are, we just count how many counters are in one of those groups.
Right.
So if we do 12 divided by 3,
We'll get 4.
we get 4.
So there are 4 girls.
Exactly.
Okay.
And here's the aha moment.
Okay.
Finding 1/3 of 12 is the exact same thing,
Mm.
mathematically, as dividing 12 by 3.
Wow. Yeah, it is.
So that line in the fraction
Yeah.
isn't just separating the numbers, it's a division symbol in disguise.
It is. It's like it's been hiding in plain sight this whole time.
Right. It's crazy.
It's so cool.
And the source even gives us a really helpful math tip
Okay.
that kind of spells this out.
Mm-hmm.
It says the denominator, that bottom number,
Uh-huh.
tells you the number of equal groups you're dividing the whole into.
Right. Okay.
And the numerator, the top number,
Yep.
tells you how many of those groups you're interested in.
Okay.
So when you see 1/3 of 12,
Mm-hmm.
that 3 on the bottom tells you to divide 12 into 3 equal groups.
Right.
And the one on top tells you to look at just one of those groups.
Okay.
So really anything 1 over n
Mhm.
of a whole is just saying how many groups of n fit into this whole.
Right.
So it's just division.
That's so cool. I never thought about it that way.
Yeah, it's really neat.
It's really interesting.
Okay, so then they give us some more examples.
Yep.
And they even draw it out for us visually with the counters.
Mm-hmm.
So to find 1/3 of 21,
Uh-huh.
we imagine 21 counters
Yep.
split into 3 equal groups.
Right.
and we find that there are 7 counters in each group. So 1/3 of 21 is 7, same as 21 divided by 3.
Exactly.
They do the same thing with finding 1/4 of 24.
Okay.
So 24 counters divided into 4 equal groups of 6.
Yep.
Confirming that 1/4 of 24 is 6, just like 24 divided by 4.
Cool.
Okay, so then in the example section,
Uh-huh.
they take it a step further,
Okay.
and they ask us to complete some statements.
Mm-hmm.
So like to find 1/4 of 12,
Uh-huh.
divide 12 into 4 equal groups.
Right.
Each fourth has blank counters.
Okay, yeah, so the answer would be 3.
3. Yeah, exactly.
Okay.
So it's just really making sure that you understand the language
Right.
and the process.
The steps.
Yeah, exactly.
Cool.
Okay, so then they have this really great illustration
Okay.
with a character named Ahmad,
Okay.
and he has 12 counters.
Mm-hmm.
And
Yeah.
he shows us how dividing them in different ways relates to fractions.
Okay.
So first he splits them into 2 equal groups.
Oh.
And we see that 12 divided by 2 is 6, and that 1/2 of 12 is also 6.
Right.
Then he divides them into 4 equal groups.
Mm-hmm.
So 12 divided by 4 is 3.
Yeah.
So 1/4 of 12 is 3.
Makes sense.
And then finally into 6 equal groups.
Okay.
12 divided by 6 is 2.
Mm-hmm.
So 1/6 of 12 is 2.
Okay.
And what's really cool about this is you can see as the number of groups,
The denominator.
the denominator,
Uh-huh.
gets larger, the size of each group gets smaller.
Right.
So it's just a really nice visual illustration of that relationship.
I like how they use the visuals to drive the point home.
Yeah, it's really helpful.
Yeah.
Okay, so then the check exercise
Mm-hmm.
gives us 8 counters this time.
Okay.
And they're divided into different numbers of equal groups.
Uh-huh.
And for each division, we have to write down the division equation
Okay.
and the fraction that represents each group.
Gotcha.
So for example, if 8 counters are divided into 2 groups,
Mm-hmm.
the division equation is 8 divided by 2 equals 4, right?
Right.
Each group represents 1/2 of the total.
Okay.
So it's just really getting us to actively apply the understanding.
Yeah, we're doing the work.
Yeah, exactly.
Cool.
Okay, so then exercise 11 gives us some practice with finding fractions of numbers using division.
Okay.
So it says things like find 1/2 of 8,
So 8 divided by 2, which is 4.
which is 4. Yep, exactly.
Easy.
1/3 of 18,
Okay, 18 divided by 3, which is 6.
which is 6.
Yep.
1/4 of 20.
20 divided by 4 is 5.
5, exactly.
Okay.
And then they throw in some comparison questions too,
Okay.
where they ask you to use less than, greater than, or equal
Mm-hmm.
to compare different fractional parts.
Okay.
So like 1/6 of 24
Uh-huh.
compared to 1/4 of 12.
Oh, okay. Interesting.
And so you really have to kind of do that mental math
Mm-hmm.
and apply the division principle
Yeah.
to figure it out.
Oh.
Okay, so then exercise 7 takes us into word problems. So this is where we get to see how these ideas actually play out.
In the real world.
In the real world, yeah.
Gotcha.
So it gives us scenarios where we have to divide counters into fractional parts
Mm-hmm.
and find a fraction of a whole.
Okay.
So it's just kind of applying it in a more concrete way.
Yeah, makes sense.
Okay, so then we have exercise 8.
Okay.
This one features Muhammad,
Hey, Muhammad.
and he has 12 apples.
Lucky him.
And he wants to share them equally among his friends.
Okay.
So first he shared them between 2 friends,
Uh-huh.
then 3, then 4, and then 6.
Okay, so we're changing the denominator each time.
Yep, exactly.
Oh,
And for each of these scenarios, we have to figure out 2 things.
okay.
How many apples each friend gets,
Mm-hmm.
which
Right.
is just the result of the division,
Right.
and what fraction of the total apples each friend receives.
Gotcha.
So if he shares with 2 friends,
Mm-hmm.
each friend gets 6 apples,
Right.
which represents 6 out of 12, or 1/2 of the total apples. So again, it's just connecting that division
Yeah.
with the fractional representation.
Right.
Okay.
Yeah.
So then exercises 9 and 10 continue with these word problems.
Okay.
This time we have a pizza.
Pizza.
Yeah, everybody loves pizza.
I know.
That's shared equally among 4 friends,
Mm-hmm.
and then a 6-pack of soda
Oh, nice.
that's shared equally among 6 guests.
Okay.
And for both of these, the task is to write the answer both as a division problem
Mhm.
and as a fraction.
Gotcha.
So again, just reinforcing that dual way of thinking about it.
Yeah, like those two sides of the coin.
Exactly.
Cool.
Okay, and then finally, exercise 11,
Okay, the last one.
the last one.
Yeah, almost there.
Brings in fractions of time, which is kind of interesting.
Okay.
So first we have a problem about someone who sleeps for 1/3 of a day,
Mm-hmm.
and we need to figure out how many hours that is.
Okay, so we know there are 24 hours in a day.
Right.
So we just do 24 divided by 3, which
Yeah.
is 8.
8 hours.
8 hours. Okay.
So 1/3 of a day is 8 hours.
Makes sense.
Then they have a question about summer lasting for 1/4 of a year.
Okay.
How many months is that?
Mm-hmm.
So we know there are 12 months in a year.
Right.
12 divided by 4
It's 3.
is 3. So summer is 3 months long.
Yep.
Um, and these examples are just really helpful because they show you
Mm-hmm.
how fractions and division come up
Yeah, in everyday life.
in everyday life. Yeah.
Cool.
Like, we're not just talking about abstract numbers here.
Right.
This is stuff that you actually use.
Yeah, for sure.
Okay. And then the last little piece in this section is another challenge.
Ooh, another
I know, so
charm.
many challenges.
Bring it on.
This one is more visual.
Okay.
It asks us to color in parts of circles
Mm-hmm.
to represent given fractions of the whole circle.
Okay.
So, for example, it might say color in 2/3 of this circle,
Right.
and you have to figure out,
How to divide it up.
how to divide it up and how many pieces to color in. So again, even though it's visual, it's still reinforcing
Mm-hmm.
that core understanding.
Yeah, that a fraction is just part of a whole.
Yeah, exactly.
Cool.
Okay, so that's it for our deep dive today.
Wow, that was a lot of
It
information.
was a lot of information, but hopefully it was all pretty straightforward.
Yeah.
So what would you say is the main takeaway here for our learners?
Well, I think the most important thing is to really get comfortable with those unit fractions.
Yeah.
Because they're the foundation for everything else we do with fractions.
Right.
And then once you have that foundation,
Mm-hmm.
it's really important to see that finding a fraction of a number is really just division in disguise.
Yeah.
Like, it's not some separate scary thing.
Right.
It's just something we already know how to do.
It's just another way of looking at it.
Exactly.
So that little line in the fraction,
Yeah,
it's a powerful symbol
it is.
because it represents both a part of a whole
Mm-hmm.
and the act of dividing that whole.
Yeah, so cool.
Okay, so on that note, here's a little thought to leave you with.
Okay.
We talked about that football team
Mm-hmm.
where each player represented 1/11 of the team.
Mm-hmm.
Uh-huh.
Yeah.
So what happens when the coach makes a substitution, takes one player off the field and puts another one on?
Okay.
What's really happening there mathematically, if we're still thinking in terms of fractions?
Right, because the whole is changing.
The whole is changing.
The fractions are changing.
Yeah, it's not just adding one and subtracting one.
Right.
It's a little more complex than that.
Yeah, that's a good one to think about.
So something to ponder.
For sure.
Okay, well, we hope you enjoyed this deep dive.
Yeah, thanks for joining us.
And we encourage you to look for those connections between fractions and division.
Yeah, they're everywhere.
They are everywhere out in the world.
In real life.
Exactly.
Cool.
All right, until next time, happy learning.
See ya.